Welcome to episode 2 of the FLOSS for Science podcast, the podcast about free, libre, and open source software for science. Today, Patrick and I are interviewing Laurent Cormier, a research associate in the field of composite materials at the Mechanical Engineering Department of the École de Technologie Supérieure in Montreal. Hi Laurent, could you please introduce yourself and talk to us about your research, subject, and interest?
Yes. First, thanks for inviting me to this podcast. Pleasure to meet you, Patrick, and you too, David. About my research, I've been involved in mechanical engineering research since around 2007. Yeah, when I started my master's here at the École de Technologie Supérieure. Since then I've mainly studied mechanics of composite materials, tested lots of materials, and mainly done characterization. My main topic has been the effect of temperature and loading rate on the fatigue of glass epoxy composites for the wind energy sector. So the glass epoxy composite is the main component of wind turbine blades. And here in Canada, we have quite a typical climate for operating wind turbines. So we wanted to know if there was an important effect to be expected with our cold winters. So this has been my main subject. I've been doing a lot of low temperature tests, fatigue tests, and tried to model and predict the outcome of the effect of temperature and loading frequency on those composite materials. So this was part of the WESNet program, which is a wind energy strategic network, which was founded by the NSERC, which is the Natural Sciences and Engineering Research Council of Canada. And it was actually part of a much broader project, which was also evaluating all the aspects of socioeconomics and distribution of power across the Canadian landscape, and also energy production with our a typical landscape and climate for wind energy production. So, well, this has been the subject of both my master's and PhD actually at ETS. So, and I've just been done with my PhD last semester. So, woohoo!
Congratulations for your PhD.
Yeah, thanks.
Any results you want to share with us?
Well, from my side, I think the most interesting result I had was I've been able to build a tool for predicting based on static tests at various temperature and a single set of fatigue tests at ambient temperature. I've been able to propose a model that would allow for predicting the fatigue behavior at different temperatures. So I think that's been the greatest achievement of my work, but also I've published on some more descriptive model of like viscous behavior of composites, and I think the maybe the most noteworthy result that's not like a formula or a model is that contrary to expectation, viscous effects reappear at low temperature, because in polymers there are many transition temperatures. The better known is the glass transition, but there are also low temperature transitions, and my work has demonstrated that under fatigue loading some viscous effects are also shown at these low temperature transitions, and these can affect the behavior of the material over long terms.
For our listeners that are not in mechanical engineering, could you slightly describe what is fatigue loading?
Yeah, of course. Fatigue basically is just the damage that is done to a material by a repeated loading. And if you're someone who gets easily bored and tend to play with paperclip instead of doodling in your classes, then probably you've experienced fatigue by yourself, because by bending and unbending and rebending that paperclip, it eventually failed. And that was just a fatigue failure. So that's the main example, the one that we often present. In metals, basically like in your paperclip, you have one crack that just grows every time you bend the material. In composites, there's a big difference, is that composites are basically multiple materials that are put together in one solid form, and each of these materials, they behave differently in fatigue. So you're going to have multiple little damages that just grow up, and eventually these coalesce and just generally degrade the material's performance. So contrary to metals, in metals you can just track the growth of a crack, and you're going to have a good idea of how long you still have on a metallic part. But in composites, it's much harder because the damages are located in multiple sites. It gets pretty hard to track the damage and predict the residual lifetime of a part. So you need to have some theoretical models to have a safe prediction in advance. Yeah.
Do you track the damage during the usage of the part, or do you the composite material, or do you only predict the life over without tracking the health of the composite part?
Okay. In my specific application, there was no health monitoring of the part. Okay, so there are ways. Some people just put very sensitive microphones on the parts, and every time a small cracks or a fiber breaks or anything, you can hear the event with the microphone and register it. And this can be a way to monitor the damage evolution in your part. As for my work, there was some photographic and video sequences of failing samples, but there was no formal tracking of the damage. Yeah.
Okay, sounds quite interesting. Thanks for sharing your research subject. And yeah, previous you mentioned a tool you used in your research. Can you be a little bit more specific which software or programming language you were using to develop this tool?
Yeah, actually, for my work, I've been using several programs and programming language. In terms of programming language, there was one that I think is a go-to programming language for many scientists. It's Python. Python is very versatile, and I've used it a lot for general data treatment and modeling. So I think that's maybe not the greatest tool ever, but a very nice tool to have for scientists. In Python, there are many packages that can be useful. In my particular case, I used SciPy, of course, a lot, not Plotlib for just graphing things, and SymPy also for simple calculations. So, but there are data treatment, like I'm aware of Pandas, which is a library for Python. For those people working with large data sets, it can be a great tool for data treatment. Myself, my data sets were too small, so I've looked at it, but it was not worth it for me to use it. But I have fellow researchers in the lab who used it and were very happy with it. So that's, in terms of programming language, that's the main I've used. In terms of other open or Libre programs, I think in research, one of the first thing you have to do is manage your reference. So for that I've used JabRef since almost day one. for me, it was great because it was cross-platform. So JabRef at the time was had a great advantage on that. I used both Ubuntu computer and Windows computer, and I could just manage my reference library with the same program, so that was great. For statistics, I've used R. In my case, was mainly for rank order statistics, so testing how statistical model fits my own data. So Gumpert's model, Weibull model, log normal were the ones that I used most, and R was very easy to learn for these basic manipulation of data. So rank order statistics, R is great for that. And one that maybe a lot of people know also is LaTeX. LaTeX for everything that's publishing, I'd say. So articles, conference articles, and even presentations. I've made almost all of them with LaTeX, but this came a bit later. I'd say maybe I started with LaTeX. I started my master's around 2007, if I recall correctly, and maybe more 2010 for LaTeX, yeah. A part of that, actually, I'm as a user, I really enjoy the availability of all these open source materials. So even for me, the quality of illustrations in my publication also is important. So I've also been using open source applications for image manipulation. So for vector graphics, I quite like Inkscape. It's quite good because as a vector graphic software, well, you can produce really high quality images for your research, but also if you want to reuse one of your output from Python, Matplotlib, and you saved it as a vector graphic. Let's say you want to make a presentation and reuse a graph from an article. So often in an article, the graph is going to be way too dense for using it on screen. So you can just re-edit it from Inkscape and keep high quality image instead of going back to your Python script and changing parameters and everything. So that's if you want to remove points or remove noise from the image, it's great.
Okay, sounds you used a lot of free and libre open source software for your research, and yeah, we like to know, why do you decide to use this FLOSS software or packages in your research? Was it for more a practical reason because it's free and you do not have to pay, or your institute was not offering other softwares, or is it more a philosophical reason you have behind this usage?
Well, I'd say it's both. I mean, at ETS we have a great software offering. We have paid versions of many softwares that are available, and I think that's great. But also, I think that philosophically, being able to know, even if it's not on a daily basis, that you're going to dig in the code and everything to know what's going on behind the scene in your computer, just knowing that you can do is a great thing for open source, contrary to proprietary files where you have very little, if any, idea of what's going on. So philosophically, I think it's great. Also, just the availability. I mean, if there's anything, I've been doing most of my work on my own computer. For some, it's not. You just can't do that. They work on big projects with centralized information and everything. So maybe for them, having their the softwares, open software available at any time, maybe it's not as great as an advantage. But for me, I was working on my own machine. I had all administrative rights, so just installing a software as I needed it. And one thing I really like about open source is that communities are just amazing. There are so much information that you can find on the internet and from other users, and people are eager to share their experience. And so it's much easier, I find, to find solutions to your problems with open source software than in commercial, where help is behind a paywall also. So availability, I think, and the communities, these are the main drivers for me.
Speaking of the community, are you an active member of the community of the FLOSS, or you're only external observer? Do you contribute to it? Have you any programs, sent patches, participated in the forums, given support to other users?
I've been mainly external. I have to admit, I've benefited more from open source software and the community than I've given back. I've always promised myself to get more involved, but until now, I've made some of my codes available for other people. I've one tool I've not mentioned earlier is GeoGebra, which is a mathematical software for graphing, geometry, and just general problem solving. So this is quite also community based, and you can share your programs, and I've shared some programs over there. I've also been involved in teaching, so I've made some small routines in GeoGebra for students to also go and have a look. So, but otherwise, mainly an external observer, I'd say.
There's always a start.
Yeah. Well, I think it's great that people get involved. For some of them, it's quite involved in just for the sense of community, and I expect to do that eventually, but right now I'm not at this point. Yeah.
Okay, that's fine. Thanks.
Okay, so what is your vision about FLOSS and its importance for the openness of science?
As I said before, the fact that you can just go back and see what the machine's doing for you, I think this provides more confidence in the validity of science than commercial software, which is all proprietary and hidden, can. Of course, that's a perspective. Some people may disagree, but I think that's one important thing. There's also, I'd say, a sense of belonging. If in the science, I think the open software, many scientists are sensitive to the question of openness, and many funding organizations also are becoming more aware of the importance of not only availability of scientific results, but also accessibility and everything. So for me, the use of open and libre software favors that openness and accessibility, I'd say. Apart from that, I think I was talking about the sense of belonging. I mean, in science, you want to contribute to knowledge and you want people to know things, but you also have as a scientist to be open to other people's perspective, and I think it's an example of the openness that's required for scientists, just sharing their results, sharing their how they get to their results, and I think it's just basically sharing experiences.
Yeah, thanks for this thoughtful answer. Do you think that FLOSS allows you to be a better scientist in your work?
That's a good one. I'd say FLOSS helps being a good scientist. And again, being a scientist means asking yourself questions and asking yourself what are the better ways to answer these questions. And FLOSS very often will provide a solution that's quite adaptable to building your own solution if you want. So in that way, I'd say that FLOSS allows you to be a better scientist. Also, in science, usually you're going to attack problems for which solutions are unknown or somewhat unknown. And I think that the versatility of open softwares in general, and the maybe not the upgradability, but the adaptability of these softwares and these routines, I think make it much easier for scientists. Yeah, for me personally, being a better scientist, I hope so. But in general, I think yes.
Yeah, an analogy that is often used is that FLOSS is kind of like Lego bricks that you can imbricate the way you want to make what you want out of them.
That's what I mean. You have like the basic building blocks for going to your solutions, but the solution is not provided to you. So as a scientist, I think that's exactly what you need. Yeah.
Okay, so let us flip the coin. Do you think that using FLOSS has negative impacts on your research?
Using FLOSS, I would not say on my research. I would say that there are negatives to using FLOSS for myself. Basically, I'm an engineer, so if I have to interact outside of academia, I mean, if I only concentrate on using LaTeX and Python, there are chances that when I'm trying to communicate with what I'd call the outside world, I'm going to have challenges if I want to collaborate on editing a report or anything. So you have to stay competent with the general software that other people uses. Also, I personally, the only time I'd say I've been thwarted by open source software is by not realizing that, contrary to most people believes, some journals do not accept LaTeX documents. So,
yes, unfortunately.
Yeah. So that's, so LaTeX is great, and when you finish up an article in LaTeX, chances are that you're going to be somewhat proud of it. And if you're asked to write it back in Word for publication, maybe you're going to consider a different journal instead of reediting your paper. Yeah. But generally, I think there are very few drawbacks. One more that I can think of is sometimes for like bleeding edge packages and things like that, you have to be a bit more aware of updates and versions. I've experienced times when I just updated a package and basic computation changed results. Maybe not drastically, but results changed enough for me to ask myself, what happened there? And well, it's just an update. They've changed a routine for linear regression or whatever, and results change a bit. So you have to scratch the surface a bit and see where the change come from, and can you live with the difference, and what are the causes. So you have to be a bit more aware of the development of the software, possibly than in commercial softwares. Yeah.
If you had absolutely no proprietary software available to you, is there anything you think that you absolutely could not achieve using FLOSS?
Probably nothing I could not achieve, but there are things I could not achieve with a reasonable amount of work.
Yeah, or time.
Yeah. I think in my discipline, which is composite materials, one of the limits in modeling is with finite element modeling of composites. To my knowledge, there are good FEM packages. There's the one from Électricité de France, but Codastar, exactly. But they don't do composite materials very well. Yeah. So and you can code it yourself, but it's quite involved. Otherwise, most things I don't think I would be blocked.
You probably answered that question, but it's a general question we want to answer all of our interviewee. What is your favorite text processing tool? Word, LibreOffice, LaTeX, Markdown, Emacs org mode, something more esoteric?
Well, some would say that it's not a text editing software, but I prefer LaTeX.
I said text processing tool.
Text processing tool, yeah. Yeah, I think LaTeX is really great for scientists, basically because of its ability to edit equations really cleanly, and that's great for scientific editing, and also just the general rendering of the document. I think we are getting quite used to ugly-looking text from the internet and from word processing in general. But I mean, when you start using LaTeX, at first it's you wonder, why is the software doing this and this and that to my text and placing my figures? And after a while, you realize that it's just the way that reading the text gets easier. And once you realize how much is missing from general, what you see is what you get text processor. Then once you build a sensitivity for this, I think it's hard going back. Yeah.
Okay, so the last question for this podcast would be: is there anything else you would like to share with us?
Well, no, there's not. Well, just thank you for inviting me and for providing me with this opportunity to talk about FLOSS and everything. So thanks. Yeah.
Thanks to you. So thank you, Laurent, for your time and this interview. If any of our listener wants to reach you, I would like them to contact you.
Well, they can just find me on the École de Technologie Supérieure annuary, and they are gonna get my address there, or just through my LinkedIn page, Laurent Cormier, engineer, and or ResearchGate. Yeah.
Okay, this will be all for today's episode of the FLOSS for Science podcast, and I hope you enjoyed that interview. And yeah, if you want to reach me, you can go on Twitter for DLPK.
Or you can reach me at _DBrass, or both of us at FLOSS for Science.
Yeah, and our website is located at flossforscience.github.io, where you can find all of our contact informations and a link to our GitHub page where you can submit subject ideas or future episodes. Yeah, so if you have anyone in mind or a topic you're interested, please go to our GitHub page and submit an issue there, and yeah, we get in contact with you. And yeah, you also can listen to our previous episode where David and I explained the aim of this podcast and what we want to do in future.
We both hope that you enjoyed the show and that we will see you in our next episode. Goodbye.
Goodbye.
Bye.